deposition. And it's a method where no chemicals are used. Therefore, it is considered as the most green technology from environmental point of view. Right? So, go to the next question.
So your next question is, how is it applied to the material?
You basically take the material from which you want to produce a coating and you evaporate it.
So it's done for evaporation.
And then the vapor will condense on the surface and form a coating.
So this is
But there are different ways to evaporate the material. And one is obviously thermal heating, converting from solid state to liquid and then vaporize the material. But we use a different technique which is called sputtering. When we take the material from which we want to produce a coating and bombard it with accelerated argon ions, and we knock out then due to exchange of energy, we knock out atoms from the surface, which then form the coating.
Right.
And what we do further differently is that in our university we use a method which is called high power impulse sputtering, where the energy which we apply is so high that the material simply explodes, and then the flux coming out from this material is ionized. And when it is electrically charged, because this ionized means that we have positively charged particles, you can accelerate them using electrical fields or guide them using magnetic fields, and therefore we can produce extremely dense and very strongly bonded to the surface coatings. So that is the Sheffield Hallam University patent. Right? Yeah, and we apply these high powers, which are in the megawatt ranges, in very short pulses, because if you apply them continuously, you can melt the whole system.
Yeah.
But with short pulses, you can produce this ionized flux, and then you can produce very dense coatings. So this goes to many applications, from aerospace to cutting tools, to turbine blades, to automotive components, biomedical applications, microelectronics, glass, photovoltaics, everything which needs coating can be done with this technology. And because you're so dense, you might need sometimes thinner coatings, so you can be much better in corrosion protection because the material is dense. You're excellent in high temperature oxidation resistant applications, which are turbine blades, because then the oxygen cannot penetrate and oxidize the surface. So there are lots of advantages.
You pretty much just answered 2 and 3 in the same one there.
Yeah.
So how does the PVD affect the mechanical properties in a short summary?
PVD is a surface technology. So we are modifying the surface. We are not modifying the bulk material.
Right.
So the bulk material retains its mechanical properties, but you dramatically change the properties of the surface. So you can bring some special functionalities like very low friction, for example. Say you deposit a carbon-based coating, so then the friction coefficient goes down, or you deposit electrochemically stable element, and then the corrosion resistance is improving. Or you combine materials, one brings low friction and the other one improves the corrosion resistance, and you bring a third material which improves the performance with your body, which would be then biocompatible material. And this is how you modify the surface depending on the application. So for every particular application, you do the material selection. Then you need a special technology to deposit it in order to improve the structure of the coating, the bonding of the coating, the surface roughness of the coating, and then you're in business.
Okay. The final question is: any suggestions or comments on the improvement of machining titanium? As you know, it's highly reactive.
Yes, we have some coatings which are already patented, and we have ongoing projects which are confidential, and we work quite, I would say, focused on this material because it's not only, it's used at least in three very key applications like aerospace, automotive, and also biomedical applications. So all these implants, titanium. It's a soft material. It's very easy to cut, but then it is very reactive material, metallurgically reactive. So it reacts with your cutting tool and masks the cutting edge by forming so-called build-up edge. So your geometry is lost, and therefore the lifetime of such tool is very low.
Yeah.
So you need a very special coating which prevents formation of build-up edge. And you cannot find material which is not reacting with titanium, basically, most of the materials. And what we have done, we have designed a very special structure in the coating which changes the wear mechanism of the material. So if you think about applying a friction force and then producing a wear particle which is removed from the surface, and if this is your wear mechanism, we have introduced a different type of structure which wears layer by layer by layer by layer, and these layers are on atomic scale, very thin. So that means that you permanently expose fresh surface. So even if your titanium reacts with this atomic layer, you will remove it. And that is the way to eventually tackle this problem. And we have such coatings.
That about wraps it up. So
Sorry?
that's about it. Thank you very
Okay.
much.